All right, so day 4, we're going to be looking at our quadrilaterals, so parallelograms. So different types of quadrilaterals, and we've already looked at parallelograms, but then proving that a quadrilateral or a parallelogram is a quadrilateral. So looking at the fact that if we have a quadrilateral and we have two pairs of opposite sides that are congruent, then it is a it is a parallelogram. Okay, so knowing these 4 theorems are very important. So we'll talk about these more in class, and why they're so important. Okay, so the first thing we're going to do, it says for what values of x and y is a quadrilateral PQR is a parallelogram. So we're just going to set these equal to each other. Let's go ahead and change this x to a y. All right, so here we go. We know in order for this to be a parallelogram, x plus 9 needs to equal 2x minus 1. And so we get subtract x. 9 equals x minus 1. Add 1. 10 equals x. Okay? All right. So actually, we got to make this a 2y for this to work. So go ahead and change that to a 2y. Okay? All right. So then also that these have to be congruent for this to be a parallelogram. So y equals 2y plus 7. Subtract 2y. Oh, I jacked this all up. We're going to get a negative and a fraction. Oh, no, just a negative. Negative y equals 7. Okay. Divide by negative 1. And y equals negative 7. So we'll deal with the negative for now. Normally won't get negatives. Okay. All right. For what value of x is a quadrilateral CDEF a parallelogram? In order for this to be a parallelogram, remember, diagonals are bisected. So if diagonals are bisected, we know that these two diagonals are congruent, and then we know that these two diagonals are congruent to each other. So we know 3x equals 5x minus 8. So we're going to subtract 5x from each side. So negative 2x equals negative 8. Divide by negative 2x. So x is 4. So it's nothing different than we've done before. Okay? So example 3 says prove that the quadrilateral ABCD is a parallelogram. So originally I was going to show you 2 new methods, but I'm only going to show you one. Okay? So in order for the quadrilateral to be a parallelogram, okay, opposite sides have to be congruent and parallel. Okay? So ignore this method 2. Okay? So what we're going to do is I'm going to first prove that they're congruent. So in order for them to be congruent, that means they have to be the same length. Okay, so congruent means the same length. Same length means they have to have the same distance. So that means we have to use the distance formula. So that's what we're going to do first, okay? So we got to make sure that AB is congruent to DC, okay? So that's what we're going to do first. Let's find the length of AB. So A is negative 3, 3, and B is 2, 5. So x1, y1, x2, y2. So square root of x2 minus x1 squared plus y2 minus y1 squared. I always put double parentheses around where I have extra negatives just so I know that those are there, okay? So that's square root, keep, change, so that's 2 plus 3. So that's 5 squared plus 2 squared. Square root 5 squared is 25 plus 4. So that gives me the square root of 29. Okay, so that's the distance of AB. So I got that first. AB is the square root of 29. Okay, now I got to find CD. So CD is, D is 0, 0. C is 5, 2. So square root x1, y1, x2, y2. So x2, 5 minus 0 squared plus 2 minus 0 squared equals 5 squared plus 2 squared equals 25 plus 4 equals 29. So CD equals the square root of 29. Okay, so we've already said that they're congruent. Great. Now we have to prove that they're parallel. So to prove that AB is parallel to DC, parallel lines have the same slope. So that means M equals Y2 minus Y1 over X2 minus X1. So let's find the slope of AB first. So AB, we've got negative 3, 3, and 2, 5, X1, Y1, X2, Y2. So Y2 minus Y1 for X2 minus X1, 2 over 5. And we've got CD, which is 5, 2, and 0, 0. X1, Y1, X2, Y2. So Y2 minus Y1 over X2 minus X1, negative 2 over negative 5, which reduces to 2 over 5. So that means AB is parallel to DC. So since AB is congruent and AB is parallel, we can say that ABCD is a parallelogram. Okay, that's it.